Today, we're going to talk about stratospheric aerosol injection, SAI for short, a relatively new and modern approach to engineering our climate and mitigating the effects of climate change. SAI involves the use of airplanes or jets equipped with gas canisters spraying aerosols like sulfur dioxide or calcium carbonate into the stratosphere in an attempt to engineer the climate by reflecting incoming solar energy. This is done in the hopes of invoking a global cooling effect. The idea takes inspiration from the phenomenon that occurs during massive volcanic eruptions, where huge volumes of ash and other particles block out the sun and can cause episodes of global cooling for years on end. One example of a research project involving this technology is the Stratospheric Controlled Perturbation Experiment, also known as SCOPE-X. This was an experiment that was to be conducted by researchers from Harvard University in Sweden and led by David Keith, a physics professor at Harvard. In 2021, they plan on doing a dry run of the device they made, launching a heavily modified propeller gondola with a specialized balloon attached up to 12.5 miles into the air, but without ejecting any aerosols. Should the project have gone through, they would have ejected about 4.5 pounds of calcium carbonate, the primary component of chalk, during their test. A very small amount of aerosols compared to something like a commercial airliner. Due to the public backlash from various Swedish environmental organizations and the indigenous Sami Council, the project has been put on hold indefinitely. Due to the SCOPE-X project being pretty much cancelled and the lack of info on successful SAI tests of this type, it's hard to say with absolute certainty what the environmental impacts of SAI can be. The intended effect is that by reflecting a portion of incoming solar radiation, global temperatures can drop a couple of degrees over a short period of time, curbing the effects of climate change and global warming. This, however, doesn't necessarily address the main reasons behind climate change, and in the best case scenario, serves as more of a band-aid than anything. In the worst case scenario, you get something straight out of the Snowpiercer movie, where SAI with an experimental compound used with the intention of cooling the Earth leads to a winter apocalypse. Or, in the real world, like the snowball Earth freeze-over that happened in the Proterozoic eon millions of years ago, a runaway, unmitigated drop in global temperatures. From a technical standpoint, the project is super feasible. The technology already exists and is functional. We have jets and airplanes that are capable of carrying loads and canisters of gases that can disperse those gases mid-flight. The challenges of utilizing SAI lie outside of technical limitations. This technology certainly has economic viability as well. Pilots would be required to fly the machines that distribute these aerosols, and chemists would be required to make gases that are potentially more effective at their intended purpose of blocking solar radiation. Jobs could be created, and the process of SAI is likely less costly than other forms of climate engineering. In order for SAI to work and be considered both socially and politically acceptable, it needs to be able to prove and demonstrate a couple things. 1. That it works as intended. 2. That it is safe and doesn't have unintended consequences. And 3. That it is a tool that is used strictly for the betterment of humanity and not used as a means to alter weather on a whim and disrupt climate for less than altruistic reasons. But with so many projects being shot down early, it's hard to say if SAI will ever get the chance to prove itself in these ways. Managing risk and uncertainty would require extensive monitoring and regulation of these projects where the use of SAI is planned. We'd need people looking at things closely in order to ensure that things are working as planned and being used in the way that they are intended. Another way to mitigate risks would be ensuring that we have methods of removing aerosols from the stratosphere just as well as we can eject it. This ensures that we have a way to pull the plug should there be an instance where SAI goes wrong. Before researching this project, I knew next to nothing about this technology. I was under the impression that SAI was a realistic premise, but something purely fictional, which is why it works so well as the premise for a movie about a fictional apocalypse. That it was something that was always seen as technically feasible, but nothing that anyone would actually try to go through with, being that it doesn't necessarily address the root causes of climate change, but rather serves as a way to mitigate its effects. With how contentious SAI is, I'm unsure if it will ever be used as a real climate change mitigation strategy. The consequences could be disastrous, or there could be none at all. Maybe it works perfectly, but we can never know for sure unless we go through with tests and make sure those tests are extensive, and that we have ways to prevent or reverse the damage that we could cause. As always, thank you so much for watching. Take care and have a great summer.